This is a continuation of our last video on inscribed angles. We've got 5 more example problems, so let's get started. So in this first example, we see that we have a quadrilateral that's inscribed in a circle. So one of our theorems was that opposite angles of a quadrilateral inscribed in a circle are supplementary. So opposite angles here, Q and 58, and then another pair of opposite angles, P and this right angle, they are supplementary. So I can set up 2 equations to solve. Q plus 58 is 180 equals 180 degrees. So Q equals 122 degrees. And then I have P, the measure of angle P, plus 90 equals 180 degrees. So P must also equal 90 degrees. So that theorem is really handy. Opposite angles of a quadrilateral inscribed in a circle are supplementary. All right, so let's take a look at this next example. I want you to notice that this line right here is a diameter. So it splits our circle in half. So this arc here is 180 degrees. So let's take a look at B first. Angle B, I'm going to trace it. It's 2 endpoints, right? Here's the vertex, but I'm looking for its endpoints, this guy and this guy. They intercept this green arc. So I know that B is half of its intercepted arc, which is 180 degrees. So B is 90 degrees. I'm also going to take a look at angle C here and notice that its 2 endpoints are the same as angle B. So I know that C is also half of its intercepted arc, which is the same arc as the yellow and the green one. So half of 100 and, okay, it's moving around on me, 180 degrees. So C is going to be 90 degrees as well. And if we had noticed, these 2 angles are inscribed in a semicircle. So we did have a theorem that said if an angle is inscribed in a semicircle, that angle is a right angle. So I should have just used that theorem to figure this out. B and C are inscribed in a semicircle. So I still have to figure out A, this little guy right here. So I know that A, this arc, the endpoints of this arc are here, and the angle that intercepts it is there, and this angle is 25 degrees. So I know that 25 degrees is half of the intercepted arc. So A is going to be 50 degrees. Okay, so now we have the theorems all about tangents and chords. So I want you to notice that we have this tangent here that hits our circle right at this point. Then we have a chord here that has these 2 endpoints on our circle. And the angle here is angle 3. We need to find the measure of angle 3. So our theorem states that the angle formed by the tangent, the green line, and the chord, the blue line, which is angle 3, is half of the intercepted arc. So the intercepted arc starts from where the chord hits the circle, okay? And it should be drawn through the angle we're looking at, through this angle 3. So angle 3, the measure of angle 3 is half of the intercepted arc, and the intercepted arc is 288 degrees. So the measure of angle 3 is 144 degrees. Okay, so let's do the next one. So now we have to find angle 2, and we can find angle 2 in a couple of ways. So if we take a look at the tangent line right here, the tangent line, we know lines form 180 degrees. So let's do this easy first. So both of these angles together from here to here should add to 180 degrees. So we have 115 degrees plus the measure of angle 2 equals 180. So the measure of angle 2 should equal 65 degrees. Okay, so that's one way we could find it. The other way we could find it is we could say, well, we know this arc or this measure here, and the intercepted arc is this big one right here. So I know that the measure of the angle, 115 degrees, equals 1/2 the intercepted arc. I'm just going to call it x. So x is going to equal 230 degrees. So this part of my arc is 230. I know in a full circle that my whole circle, the measure around there in degrees is 360. So this little part here, I'm going to call it y. If this was x, I'll call that little part y. Y is going to be 360 minus 230, which is 130 degrees. So this arc is going to be 130 degrees. So I can use for measure of angle 2, I could say the measure of angle 2 is half of its intercepted arc. And its intercepted arc starts right here, goes through the angle, through angle 2 to the end here. So that's half of 130 degrees. So I get 65 degrees. So no matter how I do it, I get the same answer. And so should you. Okay, so here for our last example, we're asked to find both angles. So I'm going to start off with finding both of the circle's arcs. So this first arc, TU, this minor arc has a measure of 128 degrees. The major arc, TVU, okay, so the green and the blue arc have to add up to 360. So 128 degrees plus the measure of arc TVS has to equal 360 degrees. So the measure of arc TVS is going to be, let's see, 260, 240, 232 degrees. So this guy is going to be 232 degrees. So I found this guy right here. So now how do I find the measure of angle 3 and the measure of angle 4? Okay, so let's start off with angle 3. Angle 3, I've got this tangent line here and this chord here. So the angle that's formed is 3 and it intercepts my green arc. Okay, so the measure of angle 3 is half the measure of the intercepted arc of 232 degrees. So the measure of angle 3 equals 116 degrees. So how about for the measure of angle 4? Well, again, it's a tangent line and a chord that forms the angle. That forms this angle right here. And the intercepted angle is my blue arc, or my intercepted arc is my blue arc. So the measure of angle 4 equals 1/2 of the intercepted angle, which is intercepted arc, which is 128 degrees. So the measure of angle 4 is 64 degrees. All right, so that's how you should do the remaining problems on your worksheet.